Imagine everything you know about how the universe began being turned upside down, because that's exactly what has happened. Scientists have managed to recreate the very first molecules ever to exist, and their results are pushing us to rethink core ideas about how the earliest stars took shape. If you think this sounds dramatic, you're right. But here's where it gets controversial. For the first time in history, researchers have mimicked the ultra-high energy conditions right after the Big Bang, successfully reproducing the primordial molecules that started it all. This achievement isn't just a technological milestone. It sets the stage for a new chapter in our understanding of star formation and the chemical evolution of the cosmos. Let's rewind time back to 13.8 billion years ago. When the Big Bang exploded matter into existence, the universe was a scorching hot soup of particles. Within seconds, things cooled down enough for the elements hydrogen and helium to form, the building blocks for everything that came later. Hundreds of thousands of years after those elements appeared, the universe had cooled sufficiently for atoms and electrons to combine, leading to the birth of molecules in various arrangements. And this is the part most people miss. The very first molecule ever formed was the helium hydride ion known as HEH+. This simple ion is key because you need it to create molecular hydrogen, the most plentiful molecule in today's universe. Both HEH+ and molecular hydrogen provided the essential ingredients for the first stars to ignite, setting the universe on course for galaxies, planets, and life itself. So, why is HEH+ so important for stars? The fusion process that powers a newborn star depends on collisions between atoms and molecules, creating the heat to sustain it. But normally, fusion doesn't work well at temperatures below 18,000 degrees Fahrenheit, about 10,000 degrees Celsius. Helium hydride ions, however, excel at facilitating these reactions even when it's relatively cool, a discovery that throws a major twist into scientific beliefs about star formation. Does the amount of HEH+ really influence how quickly the first stars came to be? According to the team's statement, the abundance of helium hydride ions in the young universe could have had profound effects on both the speed and efficiency with which stars formed and matured. Now, here's the bombshell. In their laboratory, scientists recreated early universe chemistry by chilling helium hydride ions to an astonishing -449 degrees Fahrenheit, -267 Celsius, before having them collide with heavy hydrogen atoms. The point was to see what happened when these particles interacted at different temperatures, just like those at cosmic dawn. Something surprising emerged. Reaction rates between these ions and other particles didn't decrease at lower temperatures, contrary to what earlier theories predicted. Previous models expected these chemical processes to basically slow to a crawl when things got cold. But both the actual experiments and fresh calculations debunked that, confirming that the reactions remain robust. Here's where things get spicy. This finding shakes up entrenched ideas about how stars could form in the chilly, developing universe. Study co-author Holger Kreckel summed it up, stating that interactions involving helium hydride ions appear to have played a much bigger role in shaping cosmic chemistry than scientists ever suspected. So what does this all mean? Should we rethink textbook notions of how the universe's first stars were born? Are there other overlooked cosmic ingredients that could modify our understanding even more? If you have a strong viewpoint, now's the time to share it. Does this research challenge your assumptions, or do you see other possibilities for reinterpreting the evidence? Let's get the debate rolling in the comments.